David, you finished on my desk?
Yeah, thank you.
Maddie, when you're ready. Okay. Just take a pencil back, Jill. Non-calculated part. Oh, there you go.
Show me which one is a Q&A.
Alright, kiddos, I want you to open up to the back of your spirals. Close your notes. Close your notes.
Happy birthday. Tyler, hey Tyler, I need to open to the back of my spirals. Can you do that for me, buddy?
Alright, kiddos, hold on real quick before we start this. Why? Oh, it's not up there.
That's it.
Thought I wrote it up. Why are we doing a dum-dum quiz today?
Because we like
Because we're doing a points quiz on Wednesday. Wednesday? Okay, we're doing a points quiz on Wednesday. We're doing a chapter for a quest. Actually, it's a test. I'm just saying it's not all of chapter 4. It's only 4:1 to 4:4 on Friday. Okay? So listen carefully. We're doing dum-dum quizzes today and tomorrow to get ready for the points one on Wednesday. To let you know how you are doing on the unit circle. And after a 3-day weekend, could you be a little rusty? Yes, which is why I let you study for a little bit. What are you going to do hopefully tonight?
Study more.
Yeah, exactly. Then tomorrow night?
Study.
Yeah, it's actually, that's why it's spelled, I didn't spell it. Okay, yeah.
On the Wednesday quiz, if we do well, can we also have a dum-dum?
We'll see. We'll see if I have enough for that. Okay, now, hold on. Back of your spiral's open. Here's how the dum-dum quiz is going to work. The person, back of your spiral. I want you to write down dum-dum quiz, unit circle. Unit circle, you can say unit circle quiz one, you have to write dum-dum. Okay, every other question is a speed question, meaning the first hand I see, and then I'll go ahead and like keep a track of the first few, and then until someone gets it right, they can get it done. Every other question is for speed, but that means the alternating questions, I'm going to go ahead and give 45 seconds. So if you need to write something down, if you need to work it out, etc., it lets others of you that might not be able to do the speed in the sense of super quick, but you can get it right to reward you as well. Now, on the ones that are not for speed, I'll go ahead and do a quick, I'll keep track of the time, and I'll do a quick 5, 4, 3, 2, 1, and I'll say go. And the first thing I see, if you have it right, you're the dum-dum. Ready?
Dum.
Let's start with the speed one. However, I am going to write the question down instead of saying it. You guys are going to write it with me. Okay? That way you can refer back to this maybe tonight when you're studying. You'll be like, hey, okay, cover the answers. Could I do these now? Alright? Now, some of you might be like, I'm going to write a circle and just forget the first one, or I'm going to write a table and just forget the first one. Is that a bad idea?
No.
Not if that's what works for you. Okay? Alright, here we go. Ready? Number 1. As soon as you have the right answer, because it's a speed one, raise your hand and then we'll see if you have it right. Let's do sine of pi over 3. Ricky.
Square root of 2 over 2.
No. Nathan. Square root of 3 over 2. You go high, not middle. Oh, sorry, good try. My ones that need a placement in the unit circle. It's this one. And the y-coordinate is square root of 3 over 2. Hence. Okay. This one, you get 45 seconds to work it out however you need. Ready? Number 2. Let's do cosine of 5. No, let's go 7 pi over 6. 7 pi over 6. Okay. No one raise a hand. If you have an answer right away, write it down. Otherwise.
Yeah, that's one. Root beer.
5, 4, 3, 2, 1. Down. Go. Yes. I'm going to show this one another way. 7 pi over 6. 1 and 1/6 calzones. 1 and 1/6. That is a 30-degree reference angle. That's a 30-degree reference angle. So if we're using the, you guys gonna tell me? Tell me when to go. Tell me when it hits the 9.
Use your phones.
2, 1.
I cheated. Shh. No stop.
My goodness. Look good.
This is not looking to be
Okay, how long?
That last thing isn't real.
Undefined.
It was like 25.
25?
It's like a little more.
A little more, so we'll say 30. Okay.
Yeah,
Wait. Question. Coming back. What angle did I just mark down for that 7 pi over 6? Is he a little one, 30, or a big one, 60? Little one, 30. Okay. Who am I asking for? Cosine. Go to 30. Go to the cosine. Oh. Wasn't that the answer? But what quadrant are we in? Okay, so you take the square root of 3 over 2. You say, oh, but he's in the third quadrant, so I put a negative. Why? Well, remember, both points are negative in the third quadrant. What are the points in the second quadrant? Negative, positive. How about the first quadrant? Positive, positive. How about the fourth quadrant? So all students take only tangent is positive in the third quadrant, cosine is negative, or you can take the x is negative. That's how the table works. Okay, so negative square root of 3 over 2. Number 3, speed. Number 3, speed. Let's do tangent of 7 pi over 4.
7 pi over 4. That's right before there.
Oh, darn it.
He already has one. Yeah.
What?
You do that wrong.
Square root of 3 over 3. Negative square root.
No, no.
Square root of 2.
No. Negative 1. Oops, wait, that was
That's so real.
negative 1. Hold on. I'm going to show this one a little differently. Now, guys, remember, you have to latch on to one that works for you. You can't do all these different methods in your head. But what if you hate radians? What could you do? You can convert to degrees, right? Do you remember any fourth? You can reduce, not the 4 and the 7, that doesn't work, but the 4 and 180. Do you remember what that reduces to? Every fourth always goes with 45 degrees. Every fourth always goes with 45 degrees. Every sixth goes with 30, and every third goes with, technically, 60. So you could multiply that out. 7 times 45 ends up being, that's 5, carry the 3, that's 28, 315. Some of you, that's going to be the best way for your brain to find these angles. What quadrant is 315? Not 90, not the first quadrant, not 180, not the second quadrant, not 270, not the third quadrant. Where must he be? Fourth quadrant. And what did we already figure out was his reference angle? 45. So let's say you were to throw in the geometry of it, and you were to throw in the 1, 1, root 2, and you would say, oops, that's not a root 2. That's a positive, that's a negative because it's going down. Tangent is opposite over adjacent. Oh, -1. Let's say you're like, wait, I'm still trying to figure out that table thing. We said it was a 45, right? Tangent of 45, right? Go find 45, go find tangent. Oh, 1. But in the fourth quadrant, what's tangent? Positive or negative? Negative. So it's negative. Now, Luca taught honors pre-cal, a little song that goes with this chart. Not that you have to use it. I guess in Brazil, this is what his teacher taught him. Did I already give it to you guys? No. He kind of ignored these ones because he's like, oh, those are easy. Those are easy. But either way, he ignored the zeros and the 90s because he said on those ones you can just kind of make the points and you have your whole like 1, 0, 0, 1, etc., etc. So the song isn't for that. And the song doesn't give signs or square roots. But I guess his teacher, and I don't know, you should come in here and sing it, but something like 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, 1 square root of 3. Now you're like, wait a minute, it's wrong! Yeah, exactly. That's pretty much how it was. It's hard for me to totally reenact it for you. But, it's okay, just ask him. So it's 1, 2, 3, 3, 2, 1, all over 2. Square root of 3. Wait a minute, that's not what I wrote. Hold on. Square root of 3 over 3. What does that rationalize to be?
1, 2, 3.
If you were to multiply mine by square root of 3 over square root of 3, you would get his. So his is all nice and rationalized. Square root of 3 over 3, 1 square root of 3. Now the struggle is, his doesn't say square roots, but square root of 1 is 1, square root of 2, square root of 3, square root of 3, square root of 2, square root of 1 is 1. So it leaves a little bit lacking, but it is a way, just in case you're still trying to figure out a way. Alright, this one, 45 seconds. We're only going to 5. One more slow one and one more speed one. What if I was to ask you for cosecant of 5 pi over 6? Oh, the first thing you have to know is cosecant is 1 over sine. Go. Welcome. Cheating. A little bit, Caleb.
-1/2.
No.
Darn it.
But you're close, Ashley. 2. What quadrant? Who figured out the quadrant? Show me on your fingers. What quadrant? 1, 2, 3, or 4. Show me on your fingers. Come on, I want to see. What quadrant? Come on, let me see. Majority of us are good. 5 pi over 6. 5/6 of a half circle. He's over here. His reference angle was, some people need this. What's his reference angle? 30. He's a 1/6 of 180, which is always 30. And I remember it, well, first of all, cosecant is 1 over sine. We have to know that. But then sine is up a little. Up a little is 1/2. So what's 1 over 1/2? 2. Another way of thinking about it. The 1/2 was the y value. Yeah.
Would you have accepted 1 over 1/2?
I probably would have accepted 1 over 1/2.
Dang,
Although
it
you
should
should be able to look at two. Alright, last one, speed. Last one, speed. How about secant of 2 pi over 3? Rationalize or non-rationalize, I don't care.
I don't have one, I got it wrong.
You got it wrong again? Ricky, go.
Negative square root of 3 over 3. No!
No, let me tangent one.
Gosh,
Have a
dang
tangent
it.
It's okay. Awesome. Close, but no. You already have one. I know. Oh, come on, somebody.
If there's nobody
Wait.
else, just call on me.
Hey,
There's
no.
Nathan and you and Mason.
Yeah, but
And you all three have one. Caleb, do you have one yet?
I think, no, I don't.
Okay, go ahead.
It's 2 and the square root of 3 over 3.
Oh, that's
Negative.
actually what I meant it to be, but I gave you the wrong one for that.
Darn it. Stupid.
Wrong, but I want. This is cinnamon, and I feel cheated.
Yes, Maddie got it.
That's what I got.
-2.
I just don't want to. This is cinnamon. Nobody wants cinnamon.
Well, you're eating it.
Well, yeah, but reluctant.
Question. Hold on,
Don't complain.
Yeah,
guys.
he's not going to turn down a free lollipop.
Listen. Okay. Every step you get towards the right answer is a good step. Okay? Every step you get. So some of you weren't able to get all the steps. So let's see if you were able to get a few of them. First of all, hold up. Which quadrant? 1, 2, 3, or 4? Let me see.
2.
Okay, most of you figured out 2. Good. Now, we have to figure out 2 pi over 3. You can think 1/3. 1/3 of 180 is 60. So you could have said, hey, it's up 60. You could have thought 2/3 of the calzone. There's 1/3, there's 2/3. That could have helped. Either way, we get you to right here. Okay? Secant, who is that? You have to know this. Secant is 1 over, flip the cosine value. Cosine in a unit circle is the x value, which means over a little bit, that's a negative. -1/2, flip it, that's -2. Or you could have said, hey, it says 60. Let's go to our table real quick. 60. Cosine. Oh yeah, it's 1/2, but negative because it's in the second quadrant. Flip that. Okay. Either way, you end up with a -2. All right, cool kids. Put your spirals away. Get your notes out. We are going to section 4.3.
Are we correcting the homework?
Caleb, give me your spiral.
Are we correcting the forward dash?
Oh, yeah. Sorry, I didn't mean to put all the spiral all the way away.
It's one dude.
Grab that color pen real quick. Sorry, I apologize, but have notes close.
Oh,
There's gonna be another dum-dum quiz tomorrow. I'm ready for it, but are you?
No.
Not today, but you'll be more ready if you study tonight.
I
JJ.
need my spiral back.
All right, guys, be studying. If you need a way to personally do it, there were a couple kids last year that all the work we did in class did not help. But they came, they got whiteboards, we worked on it, and figured out a way for them. And it's still one of their favorite things, the unit circle. Go figure. Kids that are struggling in calc, but they're like, that unit circle, I got it. They came in and they asked for help, and we did it individually, okay? So, before Wednesday. Here we go. You guys have your spirals? Oh no, why are they all over the place? That's weird. You guys have your spirals because we are going to check section 4.2, but since I had you get out your notes, let's take just a second for you guys to write down the first page of notes. You were getting out your colored pens.
Yeah, we have our notes.
We're going to go to our spirals in just a second, but since I did have you get out your notes, let's go ahead and write down this page before we get away from that, just so we don't waste time. Is that somewhat even? Somewhat even. The hardest part about section 4.2 is getting down the unit circle in a way that works for you. The hardest part of section 4.2 is getting down the unit circle in a way that works for you. But a lot of you guys should like section 4.3 because it's literally Sokotoa Choshakal. Let me pull up your homework answers. Okay, number 4, odd even. Number 6, you start with and you use all of your little formulas to get down your answers. A couple more seconds, it's been on the board for, well, already a little while. If you guys can't tell, cosine should have been negative, tangent should have been negative, secant and cosecant. Number 18, 4 pi over 3, sorry, negative 4 pi over 3. That might have messed a few of you guys up. You might have been in the third quadrant, you're supposed to be in the second. Remember, negative always means you go backwards. So negative 1 full calzone, there he is, and another third. That's where you should have been, which is technically 2 pi over 3. So if you missed all of these, like say the signs were wrong, write down 2 pi over 3. That's where you should have been looking. You might have just forgot the negative, but otherwise your answers are the y is sine, the x is cosine, the tangent. If you guys notice, it's a 60 degree, which would be square root of 3. Oh, no. Over 3, 1 square root of, oh, square root of 3, whatever. It's that one in the table, but with a negative because it's in the second quadrant. Number 30. This one's a little weird. Negative pi is actually the same place as positive pi. You would have had the point negative 1, 0. Sine, steal the y. Cosine, steal the x. Tangent, y over x is 0. Cosecant, 1 over 0 is undefined. Secant, 1 over negative 1 is negative 1. And cotangent, 1 over 0 is undefined. Number 40. This would have been using those even, odd properties that we wrote down in our notes. Cosine of a negative angle stays the same. Stays the same. This is the property we wrote down. Stays the same. Secant stays the same as well, but he's 1 over, so we have to flip. But we get to keep him the same. We don't have to flip the sign. So negative for everybody. Negative for everybody. Couple more seconds. You guys have one more, right? 60? Okay. Ooh. Okay, remember, they always like explaining everything. The long story short on letter A, yes. Yes. Why? They gave you a picture in number 60, right? Let's see if I can get the whole answer of that. Where was the point? What quadrant? Was it quadrant 3? Where's the point? Oh, come on, you're supposed to write the question. Oh! What's the point? That's exactly where I want. Somewhere in the third quadrant. They didn't tell you where it was, right? But they showed you where it was. I don't know what number, what radian it is, but I know it's right there. Why will they all exist? Well, they're only not going to exist if you have a 0 being one of them, like we saw up above. Is there anything that's going to be 0 on this one? It's only 0 when it's on the axis. Sines are 0 on these, cosines are 0 on those. So nope, everybody exists. And then second of all students take. Who's negative? Everybody, but all students take. Who's the only positive guy in the third quadrant when x's and y's are both negative? Tangent. Oh, wait. And who's based on or is found from tangent? Cotangent. So tangent and cotangent are the only positive ones. Everybody else is negative. And I think that's A and B and we're done, right? Okay. Let's go back, section 4.3. Unit circle took a lot longer than I expected tomorrow. The dum-dum quiz is going to go way faster because I'm not going to be explaining stuff. We're just seeing if you can get the right answers. But remember, it's an in-between day. Use tonight to study. Tomorrow you can see how you're doing as to how you do on either the slow and or the fast ones. You are going to have more time on the quiz on Wednesday than the fast ones, but you're not going to have a lot longer than 45 to 60 seconds each. So you make sure that you have it down well. Ricky?
When are we gonna take a real quiz on the answer? Are we taking Wednesday?
So we have another dum-dum quiz tomorrow to see how you're doing after studying tonight, and then we'll have the real one on Wednesday. One more quick thing for you guys studying. I'm changing it up just a little bit than I've done in the past. You're going to have 5, kind of like you just saw me now with the dum-dum quiz. You're going to have 5, just fill in the blank. It could be like sine of 30 degrees. It could be cosecant of 5 pi over 4. It could be cotangent of pi over 2. It could be, okay, you get the idea. You're going to have 5 of those. But I'm also going to give points. Before you do any of those 5, for you to give me some representation of the unit circle. Hold on. Either. And I'm going to have both of them there, and you fill in the one that works for you. If you fill in both, maybe I'll give a little bonus. Okay. I'm going to have one quadrant before the 5. I'm going to have it all printed out. I'm I'm going to have one quadrant of the unit circle, the first quadrant, from 0 to pi over 2. Completely blank. You have to give me the angles in radians, and you have to give me the coordinate pairs. I'm going to have one quadrant of the unit circle. I'm also going to have the setup for the table. Sine, cosine, tangent, 0, 30, 45, 60. If you fill in one of those, that's part of the quiz, and then the 5 questions will sound good? If you're able to fill in both of those, a little bit of both. Cool? Now some of you are like, I don't need those. All right, cool, 3 points, right? No big deal, just fill it in. Some of you are like, I only like one of them. Okay, just fill in one of them. That's all I'm asking. Here we go. Any right triangle has, well, first of all, geometry tells us a right angle, right? And then for any given, and I marked theta as the bottom left-hand corner, just because in the unit circle, that's the angle that we're almost always looking at, not the top one. The sides can be labeled. Yes, they can be labeled X and Y, etc., as we do in the unit circle, right? X and Y, then in the unit circle, this one would be 1, but we'll just say for right now, Z. X, Y, Z. That's a kind of normal way of labeling a triangle. But geometrically, in relation to this angle right here, don't we give them other names besides variables? Exactly. So what would X be? In relation to the angle, how would we describe X? Adjacent, right? How would we describe Y? Opposite. And how would we describe Z? Exactly. See, you're going to like this section. It's a good one. So we're dealing with triangles, not just unit circle. Sine. Who does he equal? Do you remember? Opposite over. Good. Opposite over hypotenuse. Now he is, look, he is the y in the unit circle. But that's just because the opposite is the y over the hypotenuse is 1. So really the opposite over hypotenuse is a general description for sine, not just confined to the unit circle. Cosine. Who's he? Good. Who's tangent? Good. Opposite over adjacent. What have you guys studied in the past that helps you remember that? SOHCAHTOA, right? That one? Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. SOHCAHTOA, it's a super easy way. You could say it's like an Indian princess or something. I don't know. How did your teacher describe it?
SOHCAHTOA.
Is that Mr. Crocker? That sounds like what Mr. Crocker would say. However, what about the other ones?
Hypotenuse over opposite.
It's going to be hypotenuse over opposite. Why? Who is cosecant the reciprocal of? Exactly. Remember, folks. Remember my way of remembering? It might not be your way, but if you don't have a way, you may as well use mine, right? Every pair, a function with his reciprocal function needs a co, but only one. So sine doesn't have a co, he needs cosecant. Cosine already has a co, so he needs secant. Tangent, he doesn't have one, so cotangent. Anyway, hypotenuse over opposite, flip it. That's why we were flipping them in the dum-dum quiz. Secant, who's he?
Top.
Hypotenuse over
Edge.
adjacent. And who's cotangent going to be? Good, 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 good. SOHCAHTOA and SOHCAHTOA. Right? It's a way of remembering. SOHCAHTOA and SOHCAHTOA. Because we have cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent, adjacent over opposite. I guess you could find a tangent and flip it, and that's okay. That's valid. That's what we do in the unit circle. Come on, you want to say it. SOHCAHTOA. Everybody, 1, 2, 3.
SOHCAHTOA.
Thank you. I want the participating party poopers. All right. Shut. See, never forget. Hopefully you'll know what it means. All right, ready? What? Who's this? What's going on?
Evil.
Doesn't even give me an angle.
Spell it.
I can't go to the unit circle. So, wait.
Use your calculator.
Could. I'm gonna use your calculator. I mean, you could use sine inverse, but we're not there. Question. We're not there.
That's what I always do.
By the way, in your calculator, the sign -1 does not mean cosecant
Yeah.
at all.
I've learned that.
You have to do 1 over divided by sign. Come back. Hold on. How on earth are we supposed to find cosine and tangent if we don't know a triangle? But don't we? Can't 0.6 be 6 over 10? If trig is just ratios, couldn't I simplify that to be 3 over 5? Why am I writing in blue? I don't know. I did it on the page before when I did SOHCAHTOA. Who is this? Who's that? Who could he be? And who could he be? So we could label this as this and this as this? Oh my goodness, geometry tells me that. But what if the numbers weren't pretty and it wasn't a nice 3, 4, 5? What would you do to solve for that? Pythagorean theorem. A squared plus b squared is c squared. But we already, most of us had memorized a 3, 4, 5 triangle. It's a special one, right? A Pythagorean triple. So question. Without even knowing beta, and to be honest, without even really caring, who's cosine? 4/5, right? Or if we were to do decimal, if they were asking for decimals, we would do 0.8. Who's tangent? Oh, come on, SOHCAHTOA. Opposite over adjacent, which would be 0.75, right? Was that tricky? Yes. Until we went to a what? Yeah, go to a triangle. Come on, my geometry people. We just have to think a little bit outside the box, but once we have that triangle, let's go for it, yeah? Okay. Now we're not going to go too crazy. Technically, I showed this to you early so that you could be working on your unit circle. But just a quick reminder of those special triangles from geometry. What are those special angles again? It was the 30, 60. 90 is in all of them though, right? Yeah, 45. Because the 90s aren't everything, so we don't really need to say 90%. Remember, if the sides are congruent, oh, look, more geometry. If the sides are congruent, it's an isosceles triangle, the angles are congruent. If 90 degrees is one angle, 180 minus 90 is another 90 cut in half. These must be 45, 45s. This one, not so much congruent sides, but still a special triangle with 30 and 60, and of course they can show up different ways. Do you guys remember what I told you the other day? What are the ratios of 45, 45s? Square root of 2 is here. What goes over here? 1 and 1. Or if you're dealing with ratios, you could put like a little x there. Because you can, remember, triangles can be similar. They can be larger, smaller, but same congruent angles, I should say, whose sides are proportional. Lots of geometry. 30 across from him is the smallest, which will be 1. Across from 60 is the next smallest, which will be root 3. And across from 90 will be the next smallest, which will be 2. I should say the biggest. 1, 2, root 3 is the way I remember it, but some of you might have studied it with x's in there instead. Because once again, this triangle can be small or big in terms of units. But anyway, we already wrote that down, but just reminding you, since we're actually working with triangles now in this section, right? To go ahead and write those down. Uh-oh. Now, trig properties. Uh-oh. The baby got stuck. These ones look a little different than last section. Last section, we were just dealing with x's and y's, but kiddos, x's and y's, that only helps us for the unit circle. Once we get out in the real world, in the sense of out of the unit circle and just solving for those special sine, cosine, tangent values, that'll make calculations much quicker as you go up in math. Those are the ones mentally that will be required here. But once you get outside the unit circle and we're actually dealing with right triangle problems, we have to maybe think of things a little bit differently. And so to broaden, sine equals y. Cosecant equals 1 over y. We want to state the general relationships. This is a pretty stinking important table. This is a pretty stinking important table. First of all the reciprocals. As you guys are writing, make sure that you're putting the argument next to the sign. If you're not putting in theta, or you could be putting like an x, sine of x equals 1 over cosecant of x, or maybe even a t, sine of t is 1 over cosecant of t. If you're not putting anybody in there, what are you putting in your formulas? Lots of sin, and that's not good. You have to have the argument, or else it's not math. You have to have sine of theta. Put it in context, otherwise we're in some trouble. Sine of theta equals, cosine of theta equals, tangent of theta equals. Then there are the quotient identities. Tangent of theta is sine of theta over cosine of theta. I've actually been mentioning this one quite a lot. We just haven't actually written it down. And some of you already know it. Some of you have seen it before. But many of you don't have it memorized. Let me get it down. Cotangent of theta is cosine theta over sine of theta.
Could tangent of theta also be
1 over tangent.
cosecant over secant?
It could be. It could be. We're not going to see that very often, but it could be. Yeah, within each of these formulas, there's actually a lot of different variations to formulas. So Caleb, thanks for bringing that up. We're actually going to talk about that in the last one. The Pythagorean identities. Sine squared of theta plus cosine squared of theta is 1. That's like our favorite because that takes something really complicated, or at least it looks complicated, and says, oh, hey, he's really easy. He's really just 1. It comes back to actually the Pythagorean theorem. Because in your unit circle, if you're able to, I'm going to show you first quadrant. If the x and the y are sine and cosine, then technically I could label this side as cosine of theta. I could label this side as sine of theta. Theta's right there, and my hypotenuse is 1. So the reason this is called Pythagorean identities is because of the unit circle. If cosine is x and sine is y, then really that forms the parts of, or the sides of the right triangle. So cosine squared theta plus sine squared theta is 1, or sine squared theta plus cosine squared theta is 1. However, you guys are finishing writing. You could also get sine squared alone. The formula doesn't always show up exactly like it's written. Kind of like how distance equals rate times time. Don't write this down. Could also be rate equals distance over time. Oops, not times. You guys worked on this probably like in middle school math, rearranging formulas. Or you could say time is equal to distance over rate. You can take one formula and look at it many different ways, as long as you do legal math to change it. So, similarly thinking, even though it's written normally, sine squared theta plus cosine squared theta is 1. We could say cosine squared theta plus sine squared theta is 1 also. We could switch it. But even more drastically, we could get sine squared alone and say that sine squared is 1 minus cosine squared. That's also true because of that formula. So actually, I could write 2 different variations for each of these Pythagorean ones. And I could also write cosine squared theta is equal to 1 minus sine squared theta. Now, it looks like 3 formulas, but doesn't it really just come back to 1? It's just being rearranged. Same thing with this one. 1 plus tangent squared is secant squared. But I could also say tangent squared of theta equals secant squared of theta minus 1. And I could also say 1 is equal to, this is a little more awkward, but secant squared of theta minus tangent squared of theta. I'm just letting you know that these could show up differently. But what's in common? They all have squares. They all have squares. And last but not least, we could rearrange this last one to be cotangent squared is equal to cosecant squared theta minus 1, and 1 is equal to cosecant squared theta. And we're going to use these formulas a lot more actually in a future chapter, in chapter 5. But we're just kind of getting an introduction to them now, and this section just has you work with them a little bit. Now kiddos, if you look at the backboard, even though our main goal today was section 4.3, we spent some time on the unit circle, and we have a few more examples to do on 4.3. So, if you look on the calendar, tomorrow is a finish 4.3 and a start 4.4. Okay? So even though homework 4.3 is due on Wednesday, so you have a little bit more time, 4.4 isn't coming right behind it. It's actually going to be due on Thursday. It's going to be quick. So you want to start on 4.3 tonight, but what do you think is an extra reason why we didn't finish 4.3 yet? What were we working on? We were working on the unit circles. We need to work on some. And this semester is coming. We need a good quiz, okay? So, unit circle quiz on Wednesday. We're preparing for that test on Friday. Do you guys have any questions about 3.1? No, sorry, 4.1 or 4.2 homeworks? Feel free to come in. But first priority, let's get that unit circle down and start on our 4.3 homework. Jane, happy birthday.
Happy birthday, Jane.
We have about 5 seconds on 4.3.2. Guys, come in if you need anything. I'll see you later. Bye.
So good.
Let's do either Wednesday, you show up during lunch after school, or if you don't come in, then we'll just all assume in class. Is that cool? Thank you. Thanks for giving me a heads up, Maddie, I appreciate it.